Welcome. In this lecture, we will develop the lottery contract. Let's create a Solidity file and we can name it as lottery.sol. First line would be Pragma Solidity compiler version. Define the contract. Let's name it as lottery. We will need a state variable to store owner's address. So define an address data type and we can name it as owner. We also need to store the players' addresses, and this time we don't know how many players will participate in the lottery. So we will have to define a dynamic array with data type address payable. So why address payable? Because we will store the addresses of players, and if the player gets declared as winner, then the player's account address should be able to receive the prize money, and only address payable account can receive the ether. So let's define an address payable dynamic array and we can name it as players. We will have one constructor which will run once at the time of deployment, and using this constructor we will save the account address which will deploy the contract, and that is the owner's address. So create the constructor. We can write constructor parenthesis then public and brace, and inside this constructor we can write owner equal to message.sender. So there will be at least one function which will select the winner, and only owner can call that function. So we can create a function modifier to restrict the access to execute the function only by the contract owner. So we can write modifier, give it a name as owner only. So we can write modifier and we can give a name as owner only, open the brace, and inside modifier you can write if message sender equals to owner, then underscore semicolon. So we have stored owner address, we have an array list defined for players, we have created constructors, and we have also defined our modifier. So now we are all set to create our functions. We need one payable function so that players can send ethers to our contract as the lottery ticket cost. So write function, let's name it deposit, then parenthesis, make it public and payable. Inside the function we will put a required condition. Whatever the ether player is sending is equal or greater than at least one ether. So we can write require message value greater than equal to 1 ether. So please note, we can directly use word ether here. In Solidity we call it as units. We can also use way. Now this function will only execute next statement if the value is equal or greater than 1 ether. Now we can store the player, that is we can add to the player array. We will get the player address from message sender, whoever will call this function. That message sender will be holding the caller's address, that and caller is our player. And since we are storing in dynamic array, we can just use push message.sender to players array to add that player. So player is our array name, then we can use push, and in parenthesis we can pass the message sender, and it will save the address of the player. So first player will go to index 0, second player will go to 1, third will go to second index, and so on. So that's all with this deposit function. And please note, we don't need to write anything to store the amount, as amount will be automatically stored in contract with this payable function. So we are not writing here any to account. From account will be definitely the caller. The to account will automatically will be the contract address. Since this is the payable account, if you are not giving any to account, so it will go to contract address. And we are not using the transfer here. So using transfer, you can transfer amount from one account to other. So you don't need to use transfer, just have a payable function, and whoever will send the amount, that will go to the contract address. Now let's create a function to generate a random number. So write function, name it as generate the random number. We can make it private view, returns as unsigned integer, because this function will return the numbers, random numbers. So we can just write return, and then we can write kesek 256. Now as we discussed this before in our global functions as well, if I go to this smart contract global, we have discussed this here, get kesek. So kesek will always have one parameter. So we can use abi.encode packed, and we can pass multiple values here, and all those multiple values will be packed as a 1 encoded in bytes, and that will work as one argument for kesek 256, and this kesek 256 will just return you the hash. So you may just copy it if you want, or you can just write it. So let's go to our lottery contract and we can just write it here kesek. So let's remove this return. Instead of this ABCDEF, what we can pass is, we can pass some global variables actually. Now is the timestamp, current timestamp. Then we can pass block dot difficulty. We are just trying to generate a random number, so we can pass anything to make it more complex. So difficulty we can pass, we can also pass player's length because that will be also one of the variable. So I think we are all good. We have three variables here. Every time this now and block dot difficulty may change. This now will definitely change as the timestamp. This is a timestamp, right? So now ABI dot encode packed will actually encode all these three in one, and then that will act as a one argument for cassette 256. So cassette 256 will give you hash. Now we want an unsigned integer, random number. So we can actually convert that hash to unsigned integer using this join. So let's test this. Deploy the contract and click on generate. Let's make it public first, public, and then deploy it again. And now if you click on generate random number, it will give you the number. See how big this number is, right? So this is a 256 bit number you have given. Now you can imagine when we will divide it by the player's length, it will give you the remainder. The remainder will act as the index of that player list, and that will be the winner. So we'll see that how we will use this, but just to show you that we are not doing any cheating here. So this lottery system will be very robust lottery system. We can also test the players. So we have this deposit payable, right? So what we will do is, this is our owner, CA35 is our owner. So what we will do is, we will change this to any other account and we will just transfer 1 ether. That means this is a player 1 who is transferring 1 ether. So we can click on this deposit. So this is successful, 1 ether. Now select the second account as a second player and transfer 1 ether, deposit. Select the third player, transfer 1 ether, click on deposit. So we have 3 players now, right? So if you click on this players array, and now if you try to find the 0 index of this players array, you will find the first player address. If you type 1, it will give you the second player. If you type 2, it will give you the third player. So our player list is working and our owner is stored, our generate random number is working. So now we need a function to pick the winner, and that should only be run by contract owner. Now we have to write a function to select the winner and transfer prize money to the winner. So let's create the function. Write the function name. Let's name it as a pick winner. And now we can give our modifier, that's honor only, and make it public. Inside function body, let's first call the generate random number function and store the random number to local unsigned integer. So we can name it as a random number and you can use in this function. So what I'm trying to do here is, I will just save this random number generated by generate num function in one local variable. And how we can call this function? You can just give the function name and the parenthesis, so it will, whatever it will return, it will be assigned to this random number. Why we are defining this? Because we have to divide this with player's length to get the winner index. Suppose we have 8 players and we need a random number between 0 to 7, and players are stored in array starting index 0. So how we can get the index of winner? We can use mod here. Let's define a variable index and then assign the result of random number mod players dot length. Unit, and then let's define index, and now you can use random number mod players dot. So as discussed in the last lecture, if we get 20 as a random number, compute 20 mod 8. Suppose there are 8 players. 20 mod 8. It will give you remainder 4. So the fourth index of the player array will be the winner. If suppose the random number is 8, you will do 8 mod 8 and it will give you the remainder 0. That means the first person in the player's array is the winner. So there is no cheating. So now we have index of the array which can be considered as winner. Let's define a local variable with data type address payable to store the winner's address. Because we have the addresses stored in an array, we need one address, one variable where we can transfer the money. So there are many ways you can do, but we can just make it easier. We can just define one local variable, address payable, and we can name it as winner, and we can store our winner address in this local variable. So we got the index from here, and array index will give you the winner address, and we are storing in the winner. Now we can directly transfer the contract balance. So our contract balance is address this dot balance, right? And how we can use it? This is whole is balance, so we can give where you want to transfer. We want to transfer to winner, and then we can use transfer, and this will go in the bracket. So we are using here winner dot transfer member of the address. Winner is the address of the winner, then transfer, it will transfer whatever here in this bracket to this winner. And this is what? This is your contract balance. Again, remember, this is your global variable, and you don't need to define the from address here. You can just declare address this dot balance, and it will be your contract balance. And contract balance is what? All this money coming from this deposit is going to your contract. Now we have selected winner, prize money has been transferred. That means lottery is done. We should reset the player array so that we can again launch the fresh lottery whenever we want. We can reset the array as players equal to new, and you can just copy this address payable array here, and then you can assign 0. So it will reset the players dynamic array. And we are all set. So now we have the contract ready. We defined owner, we set the owner, we created modifier to restrict this pick winner function to be executed only by contract owner, and then we have a function which will generate a very robust random number which will be used to get the index of the array, and that index will be considered as the winner. And we have the payable function which will deposit all the ethers transferred by the players, and it will also store the players in the array list in the players array. Let's deploy the contract. We have the contract owner address saved in owner variable. So our owner is CA35. This is the first address. Now we can change the address and transfer ether to the contract. So it will be our first player. Click on the deposit. So first player has deposited 1 ether. Transaction is successful, and we can repeat this for few more accounts. Let's repeat for third account in the list, and it will be our second player. Repeat for the fourth account in the list, it will be our third player. Let's transfer 1 ether, and we can actually verify the player list. Pass 0 as an index, click on this player. The first player is 0x147. Second player stored at index 1 is 0x4b0. Third player is 0x583. So from the account list, we are first is the owner, second is the player, third is the player, fourth is the player. And we have this fourth as well. Let's use this as well. So select this and 1 ether deposit. So now we have 4 players, and our contract balance should be 4. So now if we just change this as a owner, if we change the owner address, because owner can only run this pick winner, and if we click on this pick winner, so first check the balance is what. So first is 87, 117, 97, 118, 87, 117, 97, 118. So if we select the winner, that 4 ether whatever we have in contract balance, that should add whoever is the winner. So click on this pick winner. So here is the transaction is successful, and we can see this is the lottery.pickWinner function. And if you just go and verify here, this first account has taken this from 87 to 91. So this is the first account is your winner. So contract is working as we wanted. One thing we can do is we can make this generate function private to make it more secure. If you again deploy it, you will not see that generate random number, and you can actually retest it. So first is your owner, and first account value 1 deposit, so it's deposited 1. Let's second account deposit 1, click on deposit. Third account ether 1 deposit. Now fourth account deposit 1, click on deposit. If you click on this pick winner, So it transferred 4 ether, and if you want to verify the player, or if you want to get the getter of the player, okay, what we can do is we can define this address payable winner as a state variable and we can verify, right? So address payable public, so we can deploy it again and we can see the winner here. Fifth one is the owner. Let's transfer some ethers and these will be a players. First is 0683, second player is 0x147, third player is 0x4b0. Let's deposit, and if you pick the winner now, since our owner is 0xdd, we have to select that one, and then if you click on this pick winner, this is the pick winner function. If you click on this winner, this is 0x147, so 0x147. So play with it, and I hope you understood how you can write this smart contract, how you can take a small project, you can do your designing, then you can figure out what type of variables you want to use, what type of functions you will have to write, and how you can actually restrict the access to those functions so that it is secured. So that's all in this lecture.